Once again, you're welcome to IGCSE Indices. This is Indices, and this is this chapter. It's very relevant for IGCSE studies. So we started with the first format, which is Indices. Now, in indices is a plural. The singular language for it is index. Index means power. So when you say index, you are actually referring to power. You actually refer to power. So what you mean is that a number to a certain power raised to the power of 3. 2 raised to the power of 3. So what it means is 2 in 3 places. 2 multiplied by 2 multiplied by 2. So that's the meaning. So when you say a number raised to 0 in index, any number raised to 0 is 1. And then when you say 2 to the power of 1 is 2. Any number raised to 1 is same as that number. If you say 1 million raised to the power 1 is equal to 1 million. If you say 1 million raised to the power of 0 is equal to 1. Any number raised to the power of 0 in indices is 1. In mathematics is 1. Any number to the power of 0 is 1. Okay. Now these are basic rules you should be very familiar with. So if I use letters, if I say a to the power of 5, what it means in this index, what it means is a multiplied by a, multiplied by another a, multiplied by another a, multiplied by another a, okay, in 5 places till we get a in 5 places. So this is what we mean by index. This is what we mean by index. Okay, a to the power of 5 means a times a times a times a. Okay, but if it becomes indices, if I'm doing a to the power of 5 multiplied by a to the power of 2, like it's not plural. It becomes plural. It's no longer index. This was just an index, but this and this together is no longer an index. It becomes an indices. Becomes indices, the plural form of index. So in indices, this is simply doing repeating this a in 5 places multiplied by a in 2 places, which we have a rule of solving and making it faster and quicker. Okay, we're going to describe the laws and rules of indices, the laws of indices. So first of all, but before we do that, let's do what we're supposed to do here. So we say a times a times a times a in 5 places. If you like, you can put a bracket to show that this is the first, this is for this a to the power of 5. Then you say multiply by a to the power of 2, which is a times a, which is a times a. So if you look at this, at the end of the day, you have a to the power of 5 times a to the power of 2. You count there 1, 2, 3, 4, 5, 6, 7. So our final answer will be a to the power of 7. Our final answer will be a to the power of 7. Okay? So, but instead of this, and likewise, before we move on, if we say a to the power of 5, a to the power of 5, divide by, in indices, divide by a to the power of 2, divide by a to the power of 2, logically, same thing. You say a times a times a times a times a times a, right? 1, 2, 3, 4, 5. All over a, that's divide, because this is division. All over a times a. So logically, in indices, what we do is to cancel out. So this cancel this. Since it's division, this remove this, and this remove this. So all we have left is a times a times a. That's a to the power of 3. That's all we have left, a to the power of 3. So what we have now is a to the power of 3. A to the power of 3. But apart from doing the problem this way, this manner, we have rules or laws of indices. We have laws of indices. Apart from doing it like this, we have what we call the laws of indices that makes this problem easier. Instead of multiplying like this, we have the laws that we apply. We call them the laws of indices. So we go to itemize them, laws of indices. We go to itemize them, and then we apply them. We go to state them, and then we apply these laws. Now, law number 1 of indices states that let's take a different something that is okay, conspicuous enough. Okay, let's say the first law of indices says a to the power of m, number 1. So we write the 1 to show that this is the first law. If we say a to the power of m multiplied by a to the power of n, this law says that this m, okay, let's make it, okay. This law says that instead of writing a in n places and a in n places multiplied by a in n places, just add the power. Just write, since the base are same, since these bases are same, you write it only once. So instead of going further, you just say m, you add the power, m plus n. This is what this law says. That this is the faster way of doing it. Now let's apply it to this problem we solved before. So if we say a to the power of 5 multiplied by a to the power of 2, the one we've solved before, the one we did manually here, the one we did here, this law says, this first law says that just take the base, since the base are same, the base is, they're both a, so write the base only once, and then add the power. Add the power. 5 plus 2. Just say 5 plus 2 here. So no need to say a times a times a times a times a times a. Just add the power. So you see, you will get what? A to the power of 7. You get 5 plus 2 is 7. So you get a to the power of 7. Is that okay? You see, it's the same answer. So instead of going this way, you apply the rule, the laws of indices, you get the problem solved like this in a twinkle of an eye. For example, if we give another example, let's say example A. Let's say we give another example using numbers. Example B, let's say we use numbers. And we say 6 to the power of 5. 6 to the power of 5. Multiplied by 6 to the power of 4. Multiplied by 6 to the power of 4. So this will simply be, apply the law, is simply saying, since the base are same, the base is this one. Since the base are same, you write it 6, then you add the power. Then for you to add the power, this must be multiplication. Okay, this first law. For first law, this must be multiplication. Then you add the power. 5 plus 4. You just say 5 plus 4. And that will be 6 to the power of what? 6 to the power of 9. That will be 6 to the power of 9. So you can say, using the law, it's faster, it's easier, it's quicker, and it's better. It's faster, it's easier, it's quicker, and it's better. Also, similarly, let's do one last one before we go to second law. If we say p to the power of, let's say p to the power of 2 multiplied by p to the power of 6. If you have this, it's so easy. Since the base are same, the base must be the same in order for you to call it first law. You say p, if the base are same, you write it only once, and then you add the power. And this must be multiplication in order for it to also be first law. So you say 2 plus 6. You say 2 plus 6, and that gives you p to the power of 8. That will give you a final answer, p to the power of 8. Okay, p to the power of 8. So that's your answer. Is that okay? So it's so easy using first law. It's so easy, right? It's so easy using first law. What if we take example that includes a bit of rigmarole here and there, mix numbers together? Let's see how we apply the first law in different style. Okay? Let's see how we apply the first law. Now, if we take, let's say example 4. Let's say example 4, if I say 3 to the power of 4 times 2 to the power of 3, 2 to the power of 3 times 3 to the power of 7 times 2 to the power of 5. 2 to the power of 5. Okay, if you look at this we can use first law. But how? the one that have the same base, you bring them together. You see, two of this term have same base, and the other two have same base. So we bring the one that has same base together, right? We bring the one that have same base together. Now let's say 3 to the power of 4. 3 to the power of 4 times 3 to the power of 7. So this one, they have same base. Then times, now we go to 2. 2, we can use a different thing to show it. 2 to the power of 3 times this one, 2 to the power of 5. So what we did was just to take this and this, because they have same base, and then this and this, because they have same base. That's what we did. We just rearranged them. That's it. So you apply first law to this one. You apply first law to this one. You also apply first law to this one. So in applying first law to this one, you say 3, since they have same base, you add the power. 4 plus 7. There times, let's see this one. 2, since they have same base, you write 2. 3 plus 5. You add the power. 3 plus 5. Okay, so now let's put the final evaluation down. 4 plus 7, 3 to the power of 4 plus 7 is 11. So you have 3 to the power of 11 here, multiplied by 2 to the power of 8. That's where you stop, because these are no longer same base, so you cannot do anything to it. So you stop here. Is that okay? That's where you stop. You stop here. This will be your final answer for this. So you see, we've applied first law. Now it's time to go to second law. Now let's take the second law of indices, law 2. So law 2, L2. We can say L2, right? Law 2. It says that a to the power of m divided by a to the power of n will simply be equal to, since they have the same base, will simply be equal to a, okay, to the power of m minus, division will be minus, we use minus for m minus n, a to the power of m minus n. Now if you look at example that we've solved before, we say a to the power of 5 divided by a to the power of 2. Let's apply this law. So if you apply a to the power of 5, if we apply the law to this example, divide by a to the power of 2, this will give us, you write a, the 5 minus 2, 5 minus 2, and this will be a to the power of 3. This will become a to the power of 3. Is that okay? So this is apply the second law. Now let's take a look at other examples for second law and see how we apply. For example, if we are asked to, this is Roman figure 1. Now let's try Roman figure 2 for second law. So let's say, for example, you give you 5 to the power of 7, 5 to the power of 7 over 5 to the power of 3, 5 to the power of 3. If you are given this, they say solve this, evaluate this, simplify this, evaluate this. These are the terms they normally use. Okay, you simply say, this is like division. This is just like this. It's just written in fractional form. It's just put in ratio form or in fractional form. They're same, okay? So it's simply written, you can write like this, 5, if you like, if you so wish, 5 to the power of 7, divide by, it's same as this, okay? It's same as this, it's same. So what you should do is, the base are same, just take the base, since they are same, and since it's division, you minus the power. 7 minus 3. So you simply say 7 minus 3, and this will be equal to 5 to the power of 4. This will simply be 5 to the power of 4. Is that okay? This will simply be 5 to the power of 4. Now let's take another example quickly. if we Roman figure 3, let's say this is Roman figure 3 question. Let's say we give you x to the power of 8, x to the power of 8, divide by x to the power of 5, divide by x to the power of 5, divide by x to the power of 5. So what we have here is simply applying the second law. Because division, once the bases are same and there's division and there's power, then this is second law. So we are applying the second law. This gives us, since the bases are both x, so you write x, and then the power, since this is division, you subtract the power, 8 minus 5, 8 minus 5, and this gives you x to the power of 3, x to the power of 3, right? So that's that for that, as simple as that. Now let's take a look at any example where we can combine the first law and the second law. I'm going to do the following two questions. We're going to apply both laws together. We're going to give you questions that will require us to apply both laws together. Questions that will require us to apply both laws together. Now let's take a look at that type of question, or those type of questions. Say, use the first and second law of indices to simplify each of these calculations. Now let's take a look at that problem. Let's say separate application problem, problem 1. Use the first law and second law to do this. Now combine together. 2 to the power of 5. You say 2 to the power of 5 times 5 to the power of 3 times 5 to the power of 3 times 2 to the power of 3 times 2 to the power of 3, 2 to the power of 3 times 5 to the power of 4, 5 to the power of 4, okay, all over 5 to the power of 2, 5 to the power of 2 times 2 to the power of 2. Now you give a problem like this. First of all, we'll do them one at a time. Let's do the numerator, collect the one with the same base together. So let's say, for example, we start with, let's take a different writing. Okay, let's take this one. Now let's say we start with 2 to the power of 5, 2 to the power of 5 times, for the numerator, then 2 to the power of 3, 2 to the power of 3. You know, these are same, right? And then we also have, we also times 5 to the power of 3 and 5 to the power of 4. 5 to the power of 3 times 5 to the power of 4. Times 5 to the power of 3 and 5 to the power of 4. And then all over, we bring this 2 to 2 first, 2 to the power of 2, and then times 5 to the power of 2. 5 to the power of 2. So you see, let's move to the next step for this question. Let's move to the next step. The next step is, these are the same. So you say 2 to the power of 5 plus 3, 5 plus 3, that times 5 to the power of 3 plus 4, right? Are you with me?
Yes.
Okay, so 2 to the power of 5 plus 3, this 5 plus 3, then 5 to the power of 3 plus 4, all over 2 to the power of 2, and then 5 to the power of 2, 5 to the power of 2. To the power of 2. Okay, now here we have the next step. Let's, instead of just going down, we have 2 to the power of 8, right? 5 plus 3 is 8. That times 5 to the power of 7. 3 plus 4 is 7. 3 plus 4 is 7. 5 to the power of 7. Then over over 2 to the power of 2 and 5 to the power of 2. Now what you observe here, this and this, we can do division. We can do second law. We can apply second law to this and this. And we can also apply second law to this and this. Right? So if we apply second law to each of these, then this will become what? This will become equal to, this will become equal to, this will become equal to 2 to the power of 8 minus 2. You understand? I just jump a step. This divide by this. Is that okay? And then times, this will be 5 to the power of 7 minus 2. Second law. I apply second law to this, second law to this. Because I cannot apply first law, numerator and numerator, and then denominator and denominator. No, because they don't have same base. But you can see, like this, they have same base. They have same base. Remember that. This and this, they have same base. This and this, they have same base. And so we can apply it. This and this also have same base, so we can apply it. Is that okay? So 2 to the power of this becomes what? This will become what? This will become equal to 2 to the power of 8 minus 2 is 6. So 2 to the power of 6 times 5 to the power of 5. That will be our final. 7 minus 2 is 5. 5 to the power of 5. So this will be our final answer for this problem. This will be our final answer for this problem, for this type of problem. Is that okay? Now let's take one more application. Okay? Let's take one more application and see, and one more question for this type. And then maybe, probably, we'll do a third law, maybe in another part 2 of third law and fourth law in part 2. Okay? Third law, fourth law, and fifth law, we do it in part 2. Okay? So, but before that, let's take one more problem. We say question 2. Let's apply this question 2. Please get ready. We're going to do some questions. We're going to do classwork. Now, let's say, for example, we have 8x to the power of 5. And then we have y to the power of 6. Y to the power of 6. All over 2x to the power of 4 and y to the power of 3 and y to the power of 3. So this one, they say evaluate this. Okay, evaluate this. In IGCSE paper, if you find something like this, it's pretty easy. So the only thing you need to know is we can simply say 8 over 2, right? This is like 8 divided by 2. Okay? You can look at this and this, they're same, this and this are same. So we can like do it as if we're doing vertically. So this is 5 to the power of x, like second law, is being applied to this and this. X to the power of 4. X to the power of 5 and x to the power of 4. Sorry, this 4. This 5. Okay? The top one, the numerator is 5. X to the power of 5 over x to the power of 4. Here you can put multiplication sign. Okay, times, look at this, y to the power of 6. Y to the power of 6 over y to the power of 3. Over y to the power of 3. So if you take a look at this, then this is easy. We move to the next step. We just say 8 divided by 2, we get 4. And then apply second law to this, we write x. See, x, 5 minus 4, right? If you apply second law to this, because they are both same base, right? I already showed you something is like this. You can write s to the power of 5 divided by s to the power of 4. It means the same thing. So it means 5 minus 4, right? That times, this one there's times here, multiplication sign. Okay, times y to the power of, this is division, second law now. 6 to the, y to the power of 6. 6 is division, and they're both y. You say minus 3. Pay attention. Minus 3. So this, the next step, you get 4 x to the power of 1, which Normally, even if you don't write it, it's okay. Then y, 6 minus 3 is what? 3. So your final answer is this. The final answer is 4x y to the power of 3. 4x y to the power of 3. Is that okay? Is that okay? Now let's do third law. Third law is
yes.
Okay, let's do third law. It's very short, so that we can do. So let's do third law. Third law, law 3 is very easy. It's called the power law. Law 3. The law 3 is called the power law. It's easy. Okay? Now for third law, it's simply like multiplicative. Simply like multiplicative. For example, if I write, look at it how simple it is. Please pay attention. It's very easy. So for third law, if we write a to the power of m, and then we put bracket, and then we put another power outside. If we have something like this, what it means is that you can simply say a. Now because of this bracket, this power will multiply themselves. M times n. This power will multiply themselves. Okay? So this is third law. Now let's give a simple case to showcase this. If I say y to the power of 5 or bracket 4, if I say y to the power of 5 bracket 4 bracket raised to power 4, not bracket 4, raised to power 4, this will simply be y raised to the power of 5 multiplied by 4. So the third law is the power law, meaning you have to multiply. Okay, and there's a bracket of between two powers. There's a bracket, meaning you have to multiply those two powers. So you say y to the power of 5 times 4 is 20. So this will be y to the power of 20. This will be y to the power of 20. So it's as easy as this. It's so easy. It's not a big deal. Now let's look at some cases. Let's say if I have, let's say example A. If I have 4 to the power of 4, 4 to the power of 4 bracket 4, 4 to the power of 4 bracket 4, if we have this will become what? We say 4 into the power of 4 times 4 into the power of 4 times 4. Okay? This will become 4 to the power of 16. 4 times 4 is 16. 4 to raised to power 16. 4 to the power of 16. Okay? Now let's take another example quickly. For B, let's say if we have g to the power of 5, this is super easy. G to the power of 5, and then we close the bracket, and we raise to power 6. This is simply because of 2 power, and the bracket separated there. It means you should multiply them. So you say 5 times 6, power 5 times power 6. This will give us g to the power of 30. This will give us g. 5 times 6 is 30. This is not g30, g to the power. This is power. Don't write them like equal. If you write something like this, the examiner will give you 0. If you write like this, the examiner will give you 0. It's not g30. It's not g30. This is g to the power of 30. You must understand the difference. You must understand the difference. Is that okay? Now let's take maybe a few cases where we need to apply these laws. Let's take few cases where we need to apply this law, or probably together with other law. Okay? Probably together with other law. Let's say problem 1. Let's say problem 1. Let's say we have b to the power of 3. B to the power of 3. Then bracket power 2 outside. There times b to the power of 7 times b to the power of 7. Because in indices, they might combine for you the laws. It's now how quickly you recognize them. This one means multiplication, okay? How quickly you recognize them that you will be able to simplify the problem as quickly as possible. So you can take a look at this now. This one alone is a third law. This is third law. So meaning, use third law to do this. After you've used third law to do this, you use first law to do whatever you get here and here. For example, this will be b to the power of 3 times 2, then multiply by b to the power of 7 on this way. So 3 times 2 will be equal to what? 3 times 2 will be equal to what? 3 times 2 is 6. So this is b to the power of 6 times b to the power of 7. B to the power of 7. Right? So when you have this will become what? You now apply first law. You see? We are combining the laws now. You now apply first law. You now apply first law. You get what? b to the power of 6 plus 7. 6 plus 7. Right? Am I right? Because you apply first law now. Have same base and they are multiplication. So you apply first law. This will give us what? B to the power of what? 13. Right? B to the power of 13. So you see, same problem. We apply third law and we also apply first law. Is that okay? Now let's quickly take a look at this one. Second illustration. Let's say we have d. Okay, this is similar to. Okay, let's just do this. Let's do this. We have d to the power of 10. D to the power of 10 divided by. So see, from this division you already know we apply second law, right? Divide by d square everything bracket another power 5 outside, another power 5 outside. So from here you know we apply third law. We apply third law. So the third law will be, first of all, let's write this one down. We say d to the power of 10, d to the power of 10, divide by, now here we apply what? Third law. By saying, since there's a bracket between two power, we will multiply them 2 times 5. We say 2 times 5. So 2 times 5, you get what? You get 10. So what we have, eventually what we have, okay, let me write this equal to, what we have is d to the power of 10, d to the power of 10, divide by another d to the power of 10. Why? Because 2 times 5 is 10. Divide by another d to the power of 10. Okay? D to the power of 10, divide by another d to the power of 10. So this is second law. This is second law. We're going to apply second law now. If we do that, this will give us, since they are same, the base is same, you just write 1d, and then since it's division, you write minus 10, you subtract the power. 10 minus 10. 10 minus 10. 10 minus 10 is what? 0. So we have d to the power of 0. Don't just write 0 down, you say d to the power of 0. And you remember when we started, we say anything to the power of 0 is 1. When we started, we say anything to the power of 0 is 1. So the final answer in this case equal to 1. Okay? In solving this, the final answer equal to 1. So I think let's look at just one problem, and then we're good to go, probably. Now, third problem, third application, combining law 1, law 2, law 3, and then if we have z to the power of 3 bracket 4 divide by z to the power of 2 bracket 5, z to the power of 2 bracket 5. These are so easy, okay? Trust me. Just go through again and again. Go through this video again and again. It's easy. So you say, you write the z. Here now you apply third law. You apply third law because there's a power and there's a bracket and another power outside. So if there are two power, one inside, one outside, you multiply the two power. So you say 3 times 4, z to the power of 3 times 4 over z to the power. Same here, same thing you do here. Since there are two power, one inside, one outside, you multiply them. 2 times 5. 2 times 5. So this gives us z to the power of 3 times 4 is 12. So we have 12 here over z to the power of 2 times 5 is 10. Z to the power of 2 times 5 is 10. So now this has been reduced to second law. This has been reduced because this is division now. This has been reduced to second law. The problem has been reduced to second law. So first we did the third law, and now we're going to do the second law. So for second law, you just write 1z, because this is same as this. See, this is same as writing like z to the power of 12 divided by, it's same thing, divided by z to the power of 10. The same thing. Whether they write in fractional form, I mentioned this before, or they write like this, it's same thing. So what we do, we just take 1z, since it's division, second law, you say 12 the power minus 10. And this will give us z to the power of 2. This will give us z to the power of 2. Okay? This will give us, and this is our final answer. Is that okay? So I think we can stop here, right? Yeah. So we can stop here. So next video we will make for the fourth law, fifth law, negative indices. Yes. Fourth law, fifth law, and negative indices, and fractional indices. So we have fourth law, fifth law, negative indices, and fractional indices. That's what the part 2 of this work will be. Okay. Thank you.